Hi, welcome. We are doing our 8-6 notes today, which is page 14 in your note guides. Today we're going to do more proportions, more ratios with similar triangles. Now we have a warm-up, so pause and set it up if you can. Remember to read it, listen to the verbiage of it, and set it up. The geometric mean, I'm going to say the geometric mean of these two things is x. So remember, geometric mean goes in these two places. So geometric mean is x. I'm going to put x here and here. The geometric mean of this and this go in the other two spots. So we have x minus 3, x plus 4. Now again, pause and see if you can work it out if you didn't set it up correctly. Here we're going to cross multiply, end up with x squared equals, I have x minus 3 times x plus 4. You can FOIL, distribute, however you want to multiply those. Again, you can set up a box out here if this, how many of you have done this before? X minus 3, x plus 4, and you multiply it to get all the terms. X squared plus 4x minus 3x will give me plus x in the middle. Negative times a positive will give me negative 12. I'm going to subtract this over, end up with 0 equals x minus 12. And add this over, end up with x equals 12. This is one that was kind of nice because it's solved. It worked out. You didn't have to factor, use quadratic formula, but be careful. Most cases you might end up having to factor. So we're going to go through some of the rules for this set of notes. Theorem 8485, triangle proportionality. The thing that's nice about this is reading it, it sounds like a lot of mumbo jumbo, but generally speaking, I don't even look at this one specifically because I don't like how it matches if you match up those. It works, but it doesn't visually match what I would see. So let's just say we're going to name these. I'm going to put an A here and a B here, a C here, and a D here. I'm going to call QT is A. Automatically, it basically sets up your proportion for you. You can set up this proportion as A over C equals B over D, and then any of the rules of proportions work. I could switch the B and the C. I could have A over B equals C over D. I could do the reciprocal property, but visually this is going to work. Same thing down here. So if you wanted to set these up again, if you know they're equal, then you know they're parallel. So this is the converse. So here, if I know they're parallel, which they showed me here, then I know the segments are proportional. If I know the segments are proportional, now I know that the lines would have to be parallel. So the converse works. So looking at this, can you set up a proportion for this problem and solve? And I'm going to start with a proportion. Hopefully you can kind of see what you're looking at. I tend to set up a chart around mine to make sure I'm being consistent. UY is parallel to VX. UV is 3 right here. UW is 18. XW is 16. And I'm looking for XY right here. Okay, so that's my variable. I see that it corresponds with this 3, so I'm probably going to put the 3 and the x together like that. Now I have to figure out what else works. Now if you guys were working ahead, the most common mistake is that we're going to use the 18 here. And it's not the 18, the 18 is the entire length, and down here, the 16 is just the part of it. So all we need is this part. You're going to have to subtract. This length will be 15. So we should use 15 and 16. Okay, so that's basically how I would set this up. I'm going to cross multiply and divide. I end up with 15x equals 3 times 16, sorry. Divide both sides by 15. Notice that I didn't multiply them together because I knew I was going to be able to simplify here. 3 divides 15 5 times. I end up with x equals 16 divided by 5, or you could also write 3 1/5. Okay, when I'm trying to be consistent, I sometimes like to name the sides. You don't have to. Obviously, we were able to set this up perfectly fine. And you may have set it up differently. As long as you have the same cross product, you were fine. I would have said that I'm going to put the top numbers on top. I'm going to put the bottom numbers on bottom. I'm going to put the numbers on the left, and then I was going to put the numbers on the right. So it just helps me to be consistent. Okay, here's another rule. This one, again, I'm going to put some letters in here. I'm going to call this A. I'm going to call DB B. I'm going to call AC C, and CB I'm going to call D. Now it's nice because, again, you can kind of see a proportion right in here. So the proportion that's going to work is going to be A over C equals B over D. And then again, anything you switch is going to work as well. I could end up with A over B equals C over D. So as long as you can set up a proportion, you can't see those, sorry. It's got to work. Okay, I'm going to go to the next page. This one, I didn't really talk about it, is if a ray bisects an angle. So I have an angle here, and this ray bisected the angle, it cut it in half. So if I have a ray that cuts the angle in half, it's going to create proportional sides with where it intersects the side. And then you're going to be able to set up a proportion so you have similar triangles. Okay, going to the next page. And now we have 3 parallel lines intersecting here. Again, I like to put the letters because it just makes more sense to me in my head if I know that if I said this was W, and this was Y, and I said this is X, and this piece was Z, it's easier for me to use a letter. So now I can say, well, W over X is equal to Y over Z. Visually, I can see the proportion, which is really, really nice in these cases. So down here, here's a bunch of examples. Remember, you always want to be able to look at the cross products and if you can simplify ratios. All right, cross products and can you simplify your ratios? Okay, so given this diagram down here, can we set it up? I, looking at this, would probably put 9 over 24, because I can see them here, 9.75 over 26. I don't really like decimals that much. 75 is 3/4. I'm going to write 9 3/4. Now, given the diagram, determine whether or not the lines are parallel. Well, if this is equal, if these do create a proportion, I know that they're going to be parallel. So I have to make sure that these are equal. I'm going to check the cross products. So I'm going to take 9 times 26. Well, actually, first, can I simplify? Here I can divide by 3. I get 3 over 8. That's going to make it a little bit nicer. I'm going to do 3 times 26 equals 8 times 9 3/4. Well, 3 times 26 is 78. 9 times 8 is 72. And 3/4 times 8, well, 4 divides 8 makes it a 2. 8 divides by 4, I get a 2 times 3, I get plus 6 here. So I get 78 equals 78. These are the same, check. So yes, we have parallel lines. So you check your cross products, simplify your ratios if you can. the cross products have to be equal, and you know the lines are parallel. Here, I know that 1, 2, and 3 are equal. I know that AB is 6. I know BC is 9. I know EF is 8. And I want to know what X is. X is this value right here. I'm going to visually, I can see a proportion. I'm going to set up this proportion. I'm going to do 6 over X equals 9 over 8. Now, if you want, remember, you can always flip-flop these things. If you wanted to rewrite this as 8 over X equals 9 over 6, and just swap those ones across, the cross products are going to be the same, you can. Then you can simplify this. So if you see that that's something you can do, look at it. You don't have to. You're going to get the same answer as long as you simplify correctly, but it's always an option if it's easier for you and you're not using a calculator. So if I were going to reduce this by 3, I'd get 3 halves. This gives me 3x equals 16, giving me x equals 16 divided by 3. There we go. Yeah, I did it the other way also. I said, well, let's say we had 9x. 6 times 8 is 48. X equals 48 over 9, divide them both by 3. You would get 16 over 3. So you're going to get the same answer either way. This next one was a little bit tricky, I think. I remember this one being a little bit tricky. Can you set up a proportion? These angles are congruent, which means that bisected the angle. I know this is 3 and this is 17, and I am looking for MN. MN is this length right here. Well, I'm also going to need, so MN is usually, that's what I'm looking for, that's what I'm going to call X. I also need to know this length though. I need to name this piece right here. Well, if this is X, and that's unknown, can I name that? So most of us are thinking here, well, the whole thing's 15 and that's X. This piece right here is going to be 15 minus X. So look at what you use your highlighters, colored pencils, whatever you guys are doing. See if you can find what the pieces you need. Now I'm going to set up the proportion, that over 3. 15 minus X over 3 equals X over 17. I'm going to cross multiply and end up with 3x equals 17 times 15 minus x. Again, you guys should pause as we go, see if you can work them out. 3x equals 17 times 15. I didn't even multiply that in my work last year. Minus 17x. Well, that's a negative. I'm going to add it over here, which is really nice because then my variables are going to be positive. Equals 17 times 15. So again, not knowing 17 times 15 unless I have a calculator, I can see though if I divide by 20, I can simplify the 15. Which means I'm going to divide by 5, I get 3 times, 4 times, 17 times 3, x equals 51 over 4, which again, I didn't have to use a calculator for any of this. Or I could also write this as 12, 48, 49, 50, 51, 3/4. Either of those answers would be sufficient for x. Now it wasn't asking me for this, so I don't have to do 15 minus that number, but you could if you needed to find the pink piece as well. Using these values, find the values of the variables. Okay, can you solve for x? Can you solve for y? I'm going to do a proportion over here for x. x one, what I would probably do, there's different things you could do. You could be looking for this piece right here and say, like we did above, you could call this 12 minus x. So you could do 2 over 12 minus x, 8 over x, but you're going to have two variables in your equation, which you may not like. So you could do the 2 over this, 8 over x. But this is actually asking for the whole length here, or showing you the whole length here is 12. Do you know what the whole length up here is? That might be a better route. If I already know that this piece is 8 and this piece is x, I can put those together over here. If I know that the whole top is 10 and the whole bottom is 12, I could set it up that way. Make sure you're consistent. I'm going to put top here, bottom here. This is the whole length, and this is the length on the right. And I'm consistent. I can work it from there. I'm going to simplify the 10 and the 12. Divide by 2, I get 5. 6. Cross multiply, I get 5x equals 48. X here equals 48 over 5. My kids are yelling. I don't know if you can hear that. Now, we do have two separate triangles. So looking at the y and the 9, it gets a little bit tricky. I have this triangle in here. This is my yellow triangle. So this on the right was part of that yellow triangle there. And then I have this larger triangle, this pink triangle here. Or these. So you could have put the pink triangle over here, the yellow triangle over here. That type of stuff will work as well. If this is tricky for you to see, I do have a suggestion that you can either color code them so you see the two different triangles, or you may want to redraw them. Because if you redraw them, sometimes it gets a little bit clearer that you're matching the 8 and the 10 up, or the y and the 9, or the x and the 12. You can see it a little bit clearer sometimes if you redraw it, so keep that in mind as well. So this one over here where I'm solving for the y is here, and it's part of the yellow. I'm going to go ahead and put the yellow triangle up top. And then I'm going to put the pink triangle down below. So the yellow y corresponds with the pink 9. Those are, you could call them, I don't really want to say base because you think base is on the bottom, but you see I've flipped it around, it's kind of the bottom of those triangles. So I called it the base, which doesn't necessarily have to make sense. The next one I'm going to do is one where not the x, because that's a variable, and I don't want to use 48 over 5, because that would be ugly. So if I could use the 8, and the 8 I know corresponds with the 10, I'm going to do that. So that would be considered basically the top side of the triangle, but I know I'm consistent. Cross multiply and divide. We end up with 10y equals 72. Oh, I could have simplified first. Y equals 72 over 10, which is 36 over 5, or 7.2. There you go. Hopefully you guys did those correctly as well. There's a few more. I'm going to pause and then I'll be right back.